All right, so we are going to go ahead and take a look at the existence of zeros, this remark right here, and we're going to apply it to example 2. So the intermediate value theorem does provide for us a way to prove whether or not a given equation has a solution. And the way we do this is by reformulating or rearranging this equation so that we can look to see if that expression has a zero. So in other words, does it equal 0? And then we can go ahead and use this existence of zeros. So the intermediate value theorem, what we did in the previous video, we had up here where our f of a and f of b were just allowed to be anywhere. Well, if we want to prove that a function has a 0, we essentially want to prove that it crosses the horizontal axis at some location. So the goal for us is to check and see, let's find some value, some x value a and some x value b, where the one is going to be negative and the other is going to be positive. Then, since the function's continuous, if we attempt to connect these two dots, then there has to be some location in the middle where the function crosses the horizontal axis. So the intermediate value theorem says we're going to call that C. If we read this theorem up here, then there is some value C where that happens. So we know that f of C equals 0 for some C between A and B. So essentially here, we just want to show that f of A has the opposite sign of f of B. It doesn't have to go negative to positive. It could go positive to negative. It just really is important that at the two endpoints, we have different signs, one positive, one negative, because then if the function's continuous, we know that if it starts off negative, for instance, and it ends positive, then, well, at some point in between, it had to have been 0. And that proves that it equals 0 at some point, which, in the context of this kind of problem, it proves that this particular equation has a solution. So let's go ahead and visualize this. So what we're going to do here is the first thing we're going to have to do is create a function from this and check to see where it is equal to 0. So to do this, we're just going to bring all of the terms to one side. It does not matter what side you bring the terms over to. Just pick a side. Usually pick whatever easiest to do. So now that we have this expression on the left-hand side, we are going to define that expression to be our function f of x. So f of x is equal to the cube root of x plus x minus 1. Now with that definition in hand, what we want to do here is prove, we're asked to prove that this equation has a solution on this interval. Well, checking that is equivalent to checking to see if this function f that we just created is equal to 0 on this interval. So let's go ahead and write that out. All right, so now we have that written out for us. So in order to determine whether or not this function f has a solution on this interval, what we're going to do here is I'm going to visualize this. So I'm going to just go ahead and draw a little, I'll just draw a little plane here. Here's our x-axis. So if we plug in the endpoints, 0 and 1, into this function, let's see what signs they are. So f of 0 is negative 1, and f of 1 is 1 plus 1 minus 1, which is 1. So we know that we are at negative 1 when x is 0, and we are at 1 when x is 1. So since this function is continuous, right, it's just a polynomial plus an nth root, which are all continuous, So we know that there's no way. So I'm not going to pretend to know exactly what this graph of the function looks like. I'm just going to, what I'm about to draw here is going to be just some arbitrary curve just for illustrative purposes. But the idea is because this is continuous, there's no way we can go from this point to this point unless we cross through the x-axis. So that right there proves to us that there does exist some intermediate value, some value in between 0 and 1, where this function is equal to 0. And since we found a location where f is equal to 0, that is equivalent to proving the existence of a solution to this equation, cube root of x plus x equals 1. So we'll just go ahead and say here, I'll summarize this by saying since f of 0 and f of 1 are of opposite signs, and our function f is continuous on closed intervals 0 to 1, there is a solution, or let's say there is a 0 on the interval, open interval 0 to 1. Therefore, the equation x cubed plus x equals 1 has a solution on the open interval 0 to 1. It's a little verbose to write all that out, but that is effectively the full argument. So for this part B here, we'll go a little bit faster here just to kind of get an idea of what a streamlined version of this process is, now that you've seen the, really the full logic over here. So to streamline this process, step 1, we are going to go ahead and let a function, let's say f, be equal to, just bring all the terms to one side. So let's make this ln x minus e to the negative x. And then let's go ahead and check to see what f of 1 is. F of 1 is ln of 1 minus e to the negative 1. ln of 1 is 0. Make sure you're evaluating these. You need to be able to evaluate these without a calculator. And this is negative 1 over e, okay? So then f of, so in particular, let's just say it's negative. We don't actually care how big or small this number is. It's negative, that's all we care about. We're just trying to show that there's opposite signs at the two endpoints. So we found 1 to be negative. Let's check the right endpoint, 2. Oops. So for 2, we'll have ln of 2, which that's not a common value in the log. You can't evaluate what that is without a calculator unless you happen to know what it is. So ln of 2 minus 1 over e squared. Well, 1 over e squared is a very small number. This right here is probably about, this is probably about 0. I'm not quite sure here. Maybe 0.1. It's fairly small. About 0.1. ln of 2, this is 0.692, roughly speaking. So this is definitely positive. You could get a calculator to check that just to be sure. So we found at the left endpoint we're negative, at the right endpoint we are positive. This means since f is continuous, so I'll just say since f is continuous, there is a 0, and therefore this equation, ln of x equals e to the negative x, has a solution on 1, 2 by the intermediate value theorem. So I should probably add that over here in the previous example. I'm just going to add in up here by the IVT, the intermediate value theorem. Okay. And that's how you prove equations have a solution if they're continuous.